Hi students, so welcome on this channel. So in today's video we are going to talk about the gravitational acceleration. You must have heard that the gravitational acceleration near the Earth's surface is 9.81 meter per second square, or we can take it as 10 meters per second square. And otherwise we say that the gravity of Earth is 9.8 meters per second square, or the gravitational field near the Earth's surface is 9.8 meters per second square. And then we say that the gravitational acceleration of the moon is g by 6. So in this video we are going to mathematically find out why the gravity of the Earth is 9.81. Okay. So for this we need to understand first the Newton's law of gravitation. So Newton's law of gravitation, if you don't know, so then in detail there is a video on this channel, you can go through that. But in short is that according to the Newton's law of gravitation, the gravitational force acting between the 2 point masses is g m1 m2 divided by r square, where m1 and m2 is the mass and the r is the distance between the point masses. Okay. Now let us take the Earth. We can consider Earth as a sphere. All right, it is a sphere, and this is the center of Earth. Okay, this is the center of Earth, and let's suppose there is some object which is kept, very small object which is kept on the surface of Earth. Now, according to the Newton's law of gravitation, if we calculate, we can consider this Earth as a point mass at its own center. So that is why this I can consider the mass here. Gravity is the Earth's mass here, and the second mass is here. So basically there are two masses like this. This you can say the capital M, mass of the Earth, and this is the small m, mass which we have kept. Okay. So then according to the Newton's law of gravitation, I can say that the gravitational force acting is F equals to G capital M small m divided by R square. R is the distance between the center of Earth and the surface of Earth, right? Will it be the radius of Earth? Yes. So radius of Earth is known to us, that is 6,371 kilometers, or approximately, if you want to take it, you can also take it as 6,400 kilometers. Okay. Now what about the mass of Earth? So mass of Earth is also known to us, that is 5.97 multiplied by 10 to the power 24 kg, or approximately, if you wish to take, you can take it as 6 multiplied by 10 to the power 24. Okay. Now what I am doing is I am calling this term as the gravitational acceleration. Okay, we are denoting this term gm divided by r square with the small g. So I can say that the gravitational force acting on the surface of the Earth is m and small g, where small g is playing a same role like F equals to ma. So a is the acceleration here, g is the acceleration because of the Earth's gravity, that is gm divided by r square. Now g is the gravitational constant, and the gravitational constant value we know, that is 6.67 10 to the power minus 11, and the unit is Newton meter square per kilogram square. Okay. So if I place this value here, then I will get a fixed value of g, that is 6.67 times of 10 to the power minus 11, and the mass of the Earth is 5.97 and 10 to the power 24. One thing, how do we know the mass of Earth? I can calculate, let's suppose this is bottle. I can calculate the mass of this bottle. I will just place this bottle on the weighing machine and I will be able to calculate. But how we calculate the mass of Earth? Okay, think about it. I'm leaving on you. Okay, if you are able to find out, just find out and say in the comments. Okay, and divided by r square, that is 6.37 10 to the power 6 in the meters and square. Okay, now you take out your calculator and do the calculation, and I guarantee you, you will get g as, okay, you may get in decimals a bit different, or otherwise 9.81 meters per second square. So now through these calculations, what is happening is we are applying the Newton's law of gravitation. With the help of the Newton's law of gravitation, we are saying that the in the Newton's law of gravitation, gm divided by r square, we are saying it as the small g, okay, and that value if you calculate on the earth surface, that is gm 9.81. What if I calculate a bit high, then this value will be lesser. Why? Because the r value will increase. Okay, if I calculate a bit inside the earth surface, then also it will be low. The reason behind it, this is, again, you'll understand that in the gravitational chapter, but in brief I can say that because the mass will change and r will change, but mass will change more and it will reduce more, so that is why even we go inside the earth, so gravity will decrease, or if we go up the earth surface, that is why gravity will decrease. So in this short video, I just wanted to discuss this. Likewise, you go through the channel, there are the other videos where you will find out the other interesting topics which will increase your interest in the physics and the science. So hope you understood this, and thank you very much.